Hello, everyone. Thank you for coming out to our last session in week 8. It is very late in the quarter. Thank you for coming out. We are going to be covering Firebase and how to use that with React Native. These are the links to the slides and the links to the README. All of the information that we covered today will be on this README and the slides. So if you ever forget, you can use these links. This is the membership portal attendance code, and it's fireside chats. And we'll be building an app called Fireside Chats. So you would get to see what it's all about. And remember to fill out the feedback form. We take our feedback really seriously. And there's also a raffle. So please fill that out. Now we're at the end. And
Okay.
this is for Eugene.
Yes. Hello, everyone. Before I pass it back to Alex, I have a couple of announcements, so bear with me. For groups, by this week, the goals should be to continue working on features. I want to preface that it doesn't have to be anything fancy. I know right now is like the most stressful part of the quarter. I know the CS32 midterm just happened, so a moment of silence for all those people. But of course, we just want you to implement something that you can show off, maybe 1 or 2 features that you learned from Hacksprint. And of course, as a reminder, if you need any help whatsoever, we do work sessions every Thursday from 6 to 7 PST. Next slide, please. Okay, second announcement. Some more details about Project Showcase, which will be the week 10's workshop slot from on Wednesday, March 10th at 6 p.m. PST. So for people who will have a finished app by then and you want to show it off, get prepared to present around a 5 to 10 minute demo of your app and its features. This is not a hard limit. You can make it as short or as long as you want. It's just to give you an estimate of how long we're expecting. Some things you want to cover are the overall vision of the app, so what you went into wanting to make. It doesn't have to be something you ended up making, as long as we see what you were thinking of in the beginning. Also the roles of each member, so what each of you did, the features you were able to implement, and sort of along those lines, the concepts you were able to bring in over from what you learned in Hacksprint. And finally, some of the challenges you faced. Maybe something didn't work as easily as you hoped, maybe combining 2 different features brought up a third problem that was unexpected, and all those things we would love to hear about. So you'll receive feedback from judges, which will most likely just be us at Hack. And next slide, please. You will get a chance to win prizes. So these are the prizes for first, second, and third place. This is in fact real money. If you win first, you get $80 Amazon gift card. Second place gets $40, and third place gets $30. And that's for the entire group. And you will also have a dev post submission where you can submit your app, and that'll be live as we come closer to the event. So whenever that comes out, I'll make an announcement about it on Discord. So that's everything for Project Showcase. Last announcement. Next slide. All right, next week's workshop, in place of a lecture from us, we'll be instead having a guest speaker coming from Facebook. So the guest speaker's name is Ram. So come learn about the history behind React and React Native. You'll also get a chance to learn about some of the design philosophies for maybe why they chose one thing over another while creating React Native. So get excited, that'll be fun, and we hope to see you there. All right, I think that's the last announcement. So I'll pass it off back to Alex and Miles for another incredible workshop.
Thank you, Eugene. This is again another reminder. Please ask any questions if you're confused. We're going to be going over a lot of content. So please feel free to drop any questions you have in the chat. So our mentors can answer that for you. And then a note on code along. We do not recommend coding along. A lot of our examples and the demo that we'll be going through today will have a lot of pre-built code. So it'll be really hard for you to follow along if you want to. So instead, we will suggest that you try to just get familiar with the syntax and the structure. All of the examples shown are in the README. So if you ever want to go back and look at it, you don't have to copy it down. Just go back to the README. Great. An outline for today. First, we'll be doing a quick recap on local storage, and then we'll be getting into what are databases and what is Firestore. And then we'll be using some time to introduce what you can do with Firestore in React Native. And then we'll be building our own demo, a real-time chat app called Fireside Chats. So let's jump into some quick recap on local storage. Local storage is a way for us to store and persist data in our applications. But what does this persist word mean? It means that when your user adds some data to the app and they close the data and they leave, and they go do other things. And when they come back, they expect that this data is still there. So an example is when you have a music app where users can create playlists. Users who make the playlist can exit the app, go do something else, and then they can come back and listen to the music and go back to the music app and expect that their playlist that they created is still there. Another thing about local storage is that it can be accessed globally in the app, so any component inside the app can access this local storage. So if you see the image on the right here, people often use this box to represent like storage, and it's because it's sort of like a box where you can put your data in, and then you can inside your app, of course, inside your phone, and you can go to this box anytime you want, and all the data that you stored in there, you would expect it to still be there in how you left it. And in React Native, the two main ways of doing local storage is async storage and secure storage. Async storage is a storage system that works asynchronously, obviously from its name, and you can draw an analogy to a public storage. So if you store your data here in your public storage, and then you leave and go and do other things, you close the app or something, you leave the country, and then you come back, and you would expect, and you go back into your public storage, you still expect your data to still be there. And the thing about async storage is that it stores data in key value pairs, which means that if you see, for example, on the right, there's a key which associates to a value. So you can use a key, or often called an identifier, to obtain its associated value. Secure storage is basically async storage, but secure, woohoo. And then, which means that you can, going back to our public storage analogy, it's our public storage, but you add a lock, you buy a lock, and then only you have the key, and then you rename your storage to private storage. And this means that whenever you store your data inside, it's locked to anybody else, but you have the key to open the storage, right? So, but its format is still the same as async storage. You're still storing data in key values in a key value method. But the difference is that all of your values are now, they make no sense to anybody else except for your app. And so if you told someone that your name was this, they think like, what planet are you from? So this is a way of storing sensitive information that we may not want other apps or other users in the same app to access. For example, your passwords or your social security numbers or your IDs. Yeah, so that's secure store, and that's it for recap, and that's actually it for me. Oh, getting out of your hair soon, and I'll hand it over to Miles. But before that, we'll be having a little bit of a poll, Great. Can I open the Lo-Fi? Oh, actually, I'll stop sharing.
So on the first question on the poll, which of the following is not a reason we use local storage? No, it is not. superior to state. Well, I guess that's more of a subjective thing, but state still plays a big role in any app, even if you are using local storage. Local storage is more just because it allows us to persist data in our app again, allows data to be accessed from anywhere in the app, and obviously it's allowing us to store data locally. And then scenarios where we might use secure store over async storage. Yeah, I think most people got it. I mean, some people thought storing Reddit post contents. I don't know how sensitive those are, but I don't know. I don't go on Reddit, so I wouldn't know. Getting people's credit card information, yeah, that would definitely be something that was sensitive. And registering users for an account with the username password, that's also definitely sensitive. Mother's maiden name, maybe debatable, I guess. But yeah, that is also probably something that is sensitive. And you might want to use secure store instead. All right. All right, so now that we've done a recap of what local storage is, I want to again iterate why exactly we use local storage in the first place, right? So this is just kind of echoing what Alex was saying, but the primary reasons are to persist data and to get our singular source of data that's accessible globally across our app, right? So persisting data meaning I can go on holiday and all my data is still there that I added, and it doesn't go away magically or something like that. And local storage is also great because of the singular source of data where you don't have to duplicate data in multiple components in your application and have redundancy and stuff like that. But there's one caveat to local storage that we may not have explicitly mentioned before. And actually, if it's actually been staring at us right in the face this whole time. It's this keyword local, right? So what is this local referring to? It's referring to the fact that local storage is only accessible on one device, on your personal device. So if a user is using your app with local storage, that local storage, whatever you put in it, while they're using it, it's only accessible from their device. And you might be wondering, why is this a problem?
Wait,
well,
Miles, I'm going to interrupt real quick.
Yes?
Does anyone see what the slide Miles is on?
Yeah, he's stuck on the poll slide for me.
Oh, I am stuck on the
Yeah.
poll slide. Let me see.
Yeah, we were looking at it for being like.
Is it changing?
Yeah,
Yes.
yeah, I see why
Okay,
do use local storage.
Okay,
Okay.
that's fine. So local storage, persist data, singular source, awesome. Caveat, it's local, only on your device. Sad news. Okay, why is this sad news? Because we want to consider if you have an application where you need communication across multiple devices. So what does this mean, right? Let's give all of our devices their own little local storage, haha, cute. And then now somehow, right, these local storage is only self-contained on their own devices. So somehow my device on the bottom here needs to get information from both of these other devices, right? They have their data, and in order for my screen or my app to show everybody's data, including mine and theirs, I need to get their data somehow. Not only this, but they need to get my data and they need to get each other's data, right? So what's happening here, it seems kind of complicated. You can imagine, I don't know, this is a simple example where there's only 3 devices, but if we had to communicate across thousands of users, does that mean we have thousands of devices communicating with each other at the same time? It just it doesn't make sense, right? So how would that even happen? Or it doesn't seem efficient, doesn't seem very simple. So local storage seems like it's the wrong way to go. So how exactly do we get this communication across multiple devices? It's a very common feature in a lot of applications. Well, enter databases. All right, so what is a database? In the most simplest of terms, a database is just anything or any entity that stores information in a quote unquote organized way. And the way that it does organize its data, its data model. Right, and so here we have some examples of, well, based on this definition, you could call them databases, right? So I have this nice passwords.txt, very safe, very secure, and okay, I guess I could accept that this is a database. It's kind of organized. Every line is one piece of data, and it's a way to store that data for later, right? So, okay, sure. Another one is Excel, right? So, sure, yeah, this is kind of an ad hoc database. Spreadsheets make sense. You have rows and columns. This is its data model, right? And then maybe some of you are familiar with more conventional database technology like MySQL, and the data model for that is using tables, right? So based on this definition I just gave you, you might be wondering then, doesn't this sound very familiar? Doesn't this sound just like async storage? Doesn't async storage do this for us, right? Async storage's data model is using key value pairs, and it stores that information in an organized way. Sounds like it classifies as a database. Well, not quite, right? So for now, we're just gonna say local storage, you had your limelight last session. We're going to kind of hone in on a more narrow definition of what database means, especially in the context of an application. So in the context of an application, for a database to be useful, usually what we have is this database acts as a central storage device for all of your users' devices, right? And what does this mean? Is just instead of communicating with each other, they just communicate with one singular database. And this database is made accessible through the internet. So this means that any device that has an internet connection can request stuff from your database, put stuff on the database, and so on, right? So let's go back to our problem, our communication across multiple devices. Right, so now we can go ahead and slap a database in here, put it on the internet, and we can solve our problem of, okay, it was really complicated to communicate with each device to each other device. So let's just have them communicate through the database, right? So this database now acts as the middleman between all of these devices. Right? So this device can send their data to this database, and my device can get that data from the database, right? So that we don't have to talk to each other. We just talk to the database, and it's very simple here, right? You can even slap on everybody's local storage here, and now the local storage would serve the purpose of just storing data that doesn't need to be shared between devices, right? So everything that actually needs to be shared goes to the database. Everything that can be contained on your own device can stay in local storage. So any questions about that before I ask you some questions? Sounds like we are good so far. Let me launch the poll. And let me attempt to see if the music will be too loud. Tell me if it is. Yell and scream. A little bit. Okay.
I think it's fine.
Okay. So we're back from the poll, and first question, why are databases useful? The answer here is all of the above. Yes, it allows us to persist data. It's an alternative to local storage, but it's better than local storage, right? It allows us to have that data centralized for many devices, not just one, and obviously also organizes the data in a way that can be easily accessed later on. Also, they're very cool. Yes. Okay, what separates a database in the context of applications from things like local storage? So they don't necessarily have better performance, and they're definitely not interchangeable. A database is much more powerful. But yes, a database is accessible by all devices through the internet. That's the main thing. And they are 6, so that one person who said it, props to you. Okay. Oh, I'm not sharing results. I'm sorry about that. Okay, 3, if you have a database, when would you still use something like state or local storage? Yes, so most of you got this. The 2 correct answers here are, if there's certain information that doesn't need to be shared across devices, you can still use local storage, or if the app is completely self-contained, right? So there would be no reason you need to share any information on the app. Maybe you still just have a database so that you can keep track of who's registered or something like that. Okay. You guys are on fire. All right, let's get it. Okay. Anyway. All right, so now we have this much better system, much simpler, where every device who's using our app is just communicating with one place. What remains to be answered, though, is what does this look like? How do we implement this, right? And this is where Firebase comes in. Actually, more specifically, Firestore. All right. So first things first, what's Firebase? In a most general way, Firebase is a group of online services or products that Google has developed and provided for us. And by us, I mean for developers. All right, so the whole point of these services is to make app development easier on you, easier on me, and overall not a painful experience, because it can be very painful sometimes. There's a whole collection of services that Firebase offers for us. We're not going to go over all of these. We do not have the time for that. We're just going to be focusing on Cloud Firestore today. And also, if you watch the extra bonus section, we will also be doing a little bit of auth. Okay, so let's get into what Firestore is. So Firestore, like I said, is the specifically is the database service provided by Firebase. We're choosing Firestore here because it's very easy and to integrate and use in an application. Unlike most conventional database technologies, which require a lot of setup and also maintenance, Firestore is kind of great in that Google is kind of doing all that for you behind the scenes. And Firestore is also very, very flexible and very scalable. And scalable here just means it can handle large amounts of data if it needs to in an efficient way. Flexible here also means that it can adapt to whatever your data needs are without like some extensive refactoring or anything like that. Okay, let's understand, before we work with Firestore, let's understand the data model, right? So every database has a data model. Firestore is no exception. So Firestore's data model is what we call a document-oriented data model. For the CS143 people, you might be more familiar with the term NoSQL. Otherwise, don't worry about that. Anyway, so what a document is, it's the basic unit of storing data in Firestore. It stores its data as key value pairs. We call these fields, or Firebase calls them fields. And it looks very much like JSON. So if you recall, JSON is just a kind of a string representation of a JavaScript object. So documents are very geared towards this JSON type of format. And every document also resides within a collection. And a collection, very simply, is just a grouping of documents. Usually we group together some related documents. So this is pretty abstract. So let's take a look at an example of what a Firestore database actually looks like. So here's an example here. And this will actually be what you see when you've created a Firestore database and you're using it. So on the left-hand side here, we have all your collections in your database. And you can have as many as you want, as long as each one of them has a unique name. And so here we have a chat room collection. And inside of our chat room collection, there are multiple documents. These documents here are representing messages. And so again, you can have as many documents as you want, as long as they are uniquely identified, right? So we have to have message 1, message 2, and message 3. And then inside of each document, we see this, JSON-like kind of structure where we have the key here and a value associated with it. And we have that for multiple fields, what they're called. And then one note I want to kind of mention before we keep going is I want you to notice that there's this document name is kind of trivial, right? It's not very meaningful. And it would be kind of annoying to just keep adding documents here by, I don't know, arbitrarily increasing this last number. So what Firestore lets you do is, if you have a case where you don't really care about the document name, you just want it to be unique, you can auto-generate those names, and they will guarantee them to be unique for you. So that's just a little note. Okay, before I get into this, are there any questions about the data model? Okay, people are complaining about NoSQL. That's fine. Okay, so I'm just going to go over the steps for setting up Firebase in your application. This is very high-level stuff, and I will be doing a short demo right afterwards. This is just more to preface you so you're not blindsided or caught off guard when we start doing it. So the first thing we need to do is set up a Firebase project. And you can do this by going to this link here, console.firebase.google.com. And it'll bring you, after you sign in, it'll bring you to a page that looks like this. And you're going to want to press this Add Project button. Once you've done that, and you go through a few steps, it will prompt you to add an app to your Firebase project. So for us, when we're doing React Native, we're going to do a web project. And this might be confusing, but React Native is technically a cross-platform way of developing. So it is more in line with a web kind of application. If you were doing iOS or Android apps here, if you were going to do this, it's more for a native type of development where you're doing like with Swift or Java Kotlin. Okay, once we've created a project and then also an app, we can add Firestore to our app now. So on the left-hand side, there will be a little bar where you can select the Firestore tab, and then you can just hit this big Create Database button. And while you're doing that, something like this will pop up during that process. For now, don't worry about it. It is big and scary, but we will see why it's used later on. Okay, and then in your actual project, in your React Native project, wherever it is, you're going to want to install Firebase first. So either use yarn here or npm. Either one is fine. Just maintain consistency. If you use yarn, do not use npm. If you use npm, do not use yarn. That's really the only rule of thumb. And this is more of a my convention, but for us, we're going to create a Firebase folder and a config.js file within that project as well. And then inside of that config, it's going to look like this. So first, we're going to import Firebase from the Firebase library we just added. And then we're going to make this Firebase config variable. And inside of this variable is going to go all this scary stuff from before. That's kind of why they provide it for you, so you can get it from the Firebase console whenever you need. And you'll just put it into this config file. And then you'll run this to initialize Firebase in your application. Yes, I forgot my slides. Okay. And then at the end of this file, we will also add a export line here. And what is this doing? It's just exporting this database or DB variable so that we can use it in other files that we need it in. And this Firebase.Firestore part is giving us access to the Firestore database in our Firebase project. Okay, any questions before I go into a short demo about that? Ding, ding, dong, bing, bing. Sounds like a no. Okay, short demo. All right, so I have gone already to the console.firebase, blah, 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 and we get this beautiful UI. We're gonna have add project here. And since today we're gonna be making a chatting app, I will go ahead and name my project Fireside Chats demo. Okay, Google Analytics, they're cool. We're not gonna use them. They require an extra step, but yeah, they're cool. I don't know. So while it's loading, after it's done loading, we will be prompted again, if you remember, to add an application to our Firebase project. So once it's done loading, I will show you what that looks like too. Okay, we're gonna go ahead and press web here. And then it'll tell you to nickname your app. And because I'm unoriginal and I don't like thinking, I will just do Fireside Chats demo again. And we're gonna go ahead and press register app. And then after this, the big scary stuff comes where you have this, oh my gosh, what is this? I don't know. I don't care. I'm gonna continue to the console. So we're gonna go over to Cloud Firestore now. And we can create this database. I just wanna make sure my screen is being shared, right? Okay, cool. Okay, well now we can go ahead and click create database. And it'll ask you to either start in production or test mode. We're gonna start in test mode. This just means that there's no restrictions on who can access or edit your database. Don't keep it on this, and actually Firebase will actually like not let you keep on it for longer than 30 days. But for our purposes, this is fine. And then it'll also ask you to set a location. This is actually just where the physical server or whatever that's putting your database on the internet is actually located. You would normally put it just wherever you think most of your users are, so that it's faster for them. But we're just going to use the default. All right. So after this is all done allocating, it's going to bring up our Firestore console, and we'll be able to actually interact with our database right after this. So awesome. And we can see we had this very familiar, looks just like what the slides had, where you can start a collection and so on. So let me just show you how you can do this in the web browser, because it's actually recommended that you like start and delete collections in the web browser rather than in your programming, like in your code. So I'll just show you what this looks like. So you're gonna click start collection. I'll just make a collection of users for example purposes. And then it'll bring you with this, and it'll tell you, I need a document ID, and I need you a bunch of fields, right? So fields for users, name makes sense, maybe an age, and then maybe also, these should be a number. And then maybe also, I don't know, my school year. I'm a junior. And then here we have an option to make our own ID, or like I mentioned before, Firestore lets you auto-generate an ID, and it's guaranteed to be unique. And since, I don't know, there's not very meaningful, there's not much meaningful ways I can name this because multiple people could have my name, I'll just do the auto ID. So we'll save that. And once it's done, you'll see that you now have a users collection, you have a document here, and this document looks like this. Okay, cool. And you can always add a new document if you want. All right, so now the second part, now that we've created a Firebase project and added Firestore to it, let's integrate it with our application, right? So this is the part where we do this stuff, right? This config.js. So I have a VS Code open here, and this is the demo project, and you'll find this in the starter code in the README, right over here. Bing, bing, bong, amazing README. And so what I've created already, I've created a Firebase folder, and in here is the config.js. And we'll see that there's already like a to-do here and replaced with personal Firebase project config. So if you want to get your personal Firebase config, you can go over to the console. You can say project settings. And when you scroll all the way down, you see this scary stuff is back here. And you can just copy and paste that. And you're going to save it. So now we have put our Firebase config in. All we need to do is add that last line where we export the DB, right? So export const DB equals firebase.firestore. Amazingness. Save that as well. All right, so that's it for this demo, at least for now. We'll come back to that application later, but this is just the setup. In the meantime, let's pull But before that, I'll see if there's any questions about that. No, apparently I am an elite and I speak language of gods. Okay, cool. Let's have that poll then. Launch. Okay, so first, back on the poll, first question, what can be stored in a document? So I don't think I went over this explicitly, so my bad for that, but the correct answers here are strings, any key value pair, collections, and arrays. And maybe it doesn't make too much sense what it means when I say collections can be stored, but there's actually, this is just a small note. You are able to make sub collections if you want to. But you can see if I want to add a specific, what is going on here? Okay, if I want to add any data type, I can have all these different data. I have a string, number, Boolean, array, and stuff like this, even like a timestamp here. And so these are all the supported things that you can store in a document. You cannot store another document in a document though. The hierarchy always goes collection, document, collection, blah, blah, blah. Okay, on to second question. What do we add to the end of our Firebase config file so that the rest of the app can use Firestore? And so we're going to export an instance of the Firebase.firestore. And just to see what that looks like in the code again, that looks like this line here. All right, so DB is just my name. You can name it whatever you want. DB makes sense to me, standing for database. Okay, question 3. What is the difference between Firebase and Firestore? Here, Firebase is the collection of services that Google provides, and Firestore is one of those services, right? So Firebase does not refer to all the databases in our app. Firebase is just like a carrier of a bunch of different things, and Firestore is the database service in Firebase. So hopefully that all makes sense. All right, so stop sharing results. All right, let's get on. Oops, oh my gosh. Okay, working with Firestore. So now that we know or we understand Firestore a little bit better, like what it looks like, let's talk about how we can actually use it. All right, so first I'm going to go over a few terminology things. These will just help you better understand the code that comes later. So bear with me. Here we have what are called references. And these just refer to a specific collection or document in your Firebase database. And this is how we do it in code, right? So here is an example of a reference to a specific collection in your database. You just do db.collection and then the name of that collection. And then here is how you reference a document in the collection. You can do the collection again, and then you have the document, and you can specify the ID of that document. Right, so notice here, all documents have to be in some collection. So that's one thing to notice by this syntax. Okay, next terminology to go over is a query. And queries in database land are just ways to say a request for data. Like if I'm asking the database to give me all of the documents in its data, this is what a query is. So queries can be constructed in a way that allows us to retrieve specific information that is relevant to us or our application. So we'll go over some examples of what this looks like. But the general syntax of what a query looks like, you have these 3 main clauses, really. You have this where and this order by and this limit. And we'll go over what these kind of look like more in depth after this slide. But notice that they're all done to a collection, a specific collection reference. Right, so just at a high level, the where clause is determining all the documents that meet some condition. The order by clause just orders or sorts the documents by some field. And the limit clause is talking about the cap or the maximum number of documents we want to get back. Okay, so let's do some examples. We have the where clause here. So db.collection users is our reference to the users collection. And now we have the where clause here, and you can see that we have age equals 21. So this query in particular is for all documents in our users collection where the age field is equal to 21. And so these can be changed out with any other type of value, right? So the age can be changed out with any key or field in our documents. The value can be changed out with any value you would like to compare the field to. And then the comparison operator here, there's a whole load of comparison operators you can use, but just make sure they're all in these little quotes. Okay, next query is the order by. Right, so we still have our collection reference here, and now we're just adding the order by, and then we have a field or a key. Right, so we're ordering this query is ordering the user's documents by their name field. And additionally, what you can do is have them either in ascending order specifically by adding a comma ascending here, or you can have them in descending order. All right, so ordering them by name, we'll just do it alphabetically. Okay, and then finally the limit is probably the most straightforward. It just places a maximum on the number of documents you should get back from your query. So this will do only the first 20 documents from our users collection. So hopefully that all makes sense. What you can also do is combine these clauses together. So it's called a compound query. So here we have all the three clauses, where, order by, and limit. And this query in particular is asking for all the documents in the users collection with age equal to 21. I want to sort them by their name field, and also I only want the first 20. So hopefully that all makes sense. Any questions before I get on to the executing queries? Okay, so looks like there aren't questions. Okay, so executing queries. So a query by itself is not that useful. It's just a way to construct what we want. But to actually get the data from our database, we have to execute the query. So this is a lot of code, but we'll break it down step by step. So because I know it can be overwhelming if you've never seen any of this before. All right, so first, let's just notice that this is in a try-catch block, and that's just for safety, right? So we'll notice there's an asynchronous call here by the await. So we always use try-catch in case something goes wrong during that asynchronous call. But the real meat of this code is happening in the try block specifically. So let's take a closer look at that. Okay, so here we have the first line is just a query, right? This is something we are familiar with from the past slides. We have a query that's getting all the users' documents with age equal to 21. But this next line here, you probably haven't seen before, but this is actually the execution line. So this is actually how we execute our query, actually ask the database for any data that matches this query. Right, so we just do await query.get, and this is an asynchronous call. That's why we're using await. And then what this gives us back is called a query snapshot. Just as at a high level, how you can understand what a query snapshot is, think of it as how the database looks, or how the data related to our query looks at the time of our query. And then at the end here, we have a snippet of code that goes through each document from our query result. And let's go into this a little bit closer, because maybe not all of you have seen this for each before. So if you are familiar with the map function, it's kind of similar. Basically, query snapshot.forEach. Query snapshot, it's not quite an array, but you can think of it here as you're going through an array of documents. And so the for each function is just going through each document and using this function that we pass in on that element. All right, so each document in our query snapshot is going to be passed into this function so we can do whatever we want with it. And so some of the things we can do is get the ID of Right. Query snapshot is an array of documents. Some of the things we can do is get the ID of the current document we're looking at, and we can also get the data. But the ID here, remember, it's referring to this ID of our document, and we can also get the data in our document as a JavaScript object. And remember, the data is just this JSON-like type of stuff. Hopefully, all that makes sense. Before I ask you some questions, let's see if there are any questions for me. Everybody is Gucci, apparently. Okay. So let me ask you some queries. Let me launch this poll. So this one's a little bit longer, so we will take a few more minutes on this. And the last question here, it's kind of messy to read, but try your best. It's more of a challenge question anyway. Let me put the music back on. And let's go over the poll answers really quick. So first question here, which of the following are true about references and queries? So there are multiple right answers here. I see the most guessed answer was we use references to build queries, and yes, that's correct. So every query looks like something like this. So the db.collection users part here is a collection reference. References are not like the works cited, and queries are not just like questions. References in our code don't really have anything to do with something like works cited. Queries are, I guess, in a way, questions, but questions for the database. Okay, and then the rest, how do you execute a query? Yep, the correct answer is await query.get. Just remember that is an asynchronous call, so we have to use the await. And then the rest of the questions here have to do with this example collection that I made earlier. And so the first one here is, how would we get a query? How would we build a query for all undergrad students? So this is just building. So we don't use await and get here because that's execution. So the correct answer here is the second answer, which is db.collection users, which is our users. Oh, actually, never mind. I bamboozled myself. The correct answer here is actually the fourth answer, because the second answer is DB collection users, but this one is for students. And I think that probably is my fault because I didn't show this earlier. But DB collection students is our students collection, and then where undergrad is equal to true. Okay, and then based on the slides collection, how could we execute a query to get all you students in a year 2 or above? And the correct answer here is the last answer. This is an execution, so we do need await and get. And so we have the db.collection students, and then where the year is greater than or equal to 2. Okay. The fifth question here, this one's a little bit, I'm a sneaky because I didn't teach you how to do things with arrays, but the correct answer here is going to be the array contains and then CS32. So that's just another comparison kind of operator we can do, but this one is for arrays specifically. And then the last question here is kind of a more challenged question. It looks like most of you got it right. I kind of expected all of you to answer bruh because it also like looks terrible to read. But this question is getting all the students with the most number of units, right? So what happens here is first we get a snapshot of all of the, well, not all of the, but we get one document from an ordered list of the documents by their units, and we do it in descending order. So that descending order would put the maximum on the top. And so if we limit 1, we only get that first document. And then we're going to go ahead and set some variable called max to the units in that document. And then we need to make another execution of a query where we compare the units field to that max variable. So this one's a little bit more complicated, but it looks like most of you got it right, actually. Okay, awesome. Whew, that was a lot. So let's go ahead. Now that we have an understanding of how to build queries, let's talk about actually doing more interesting stuff with Firestore. Like getting stuff is cool, but we want to also be able to like modify what is in our database. So first off, just adding to our database, right? So there's 2 ways to add data to your database. The first one is by this first line here. And this is if you have a specific ID in mind you want to create a document for. Right? So we'll just have a reference to a collection here, and then we will specify the ID of our new document, and we'll do .set. And then in here, we just pass a JavaScript object, and that will directly correspond to what the document ends up looking like. The same kind of thing happening here, but this one is for auto-generated IDs. So instead of doing .set and also specifying the name of your document, you just do .add after the collection reference. And again, you just pass a JavaScript object for what you want the data to look like in your document. And one thing I haven't put here, because I just want to make it simple, is these are asynchronous calls. So if we're good programmers, we should wrap them in a try-catch block. I've just not put them here for simplicity. Do note that this will be omitted in future slides as well. But whenever you see await, you should always think, oh, I need to try-catch that in case something breaks or blows up. Okay. Other thing we can do is update our database, right? So if we already have some documents in our database, we want to update them somehow. The way we can do this is by getting a document reference here. So we have a collection and then the document inside of that collection. And then we do .update, and then we pass in an object again. One thing about this object is the database will only update with the included fields in your object. So if your object has, for example, let's go back here. Let's go back to my Cloud Firestore. If our object has a name and an age field and a year field, if my object that I passed into the update function only has age and year, then it will only update age and year and it'll leave name alone. So that's how that works. And one note here, just to make sure you're aware, you have to know the ID of the document you want to update. So you cannot just update all the documents in a collection, at least not in an easy, straightforward way. You have to know the ID first. Okay. Lastly, we can also delete from our database. So if you want to delete a specific document, you again need to know that ID, and you just run .delete, right? So these functions are supposed to be made pretty easy for you to understand. Firestore is really great like that. Like I said, it's very easy to use. You just have these very straightforward add, update, and delete functions. So hopefully that all makes sense. Any questions before I go into some examples? Wait, what examples do I have? I don't think I have examples prepared, so I'll just take questions. I don't know why this slide is here. Okay. All right, so no questions. Let's get into our demo. So finally, we can apply all of this high-level stuff I've been throwing at you to an actual project. And our project here is Fireside Chats. So it's going to be a real-time chat app where anybody can just come in and start talking, you know, sit by the fire, cozy chatting, fun stuff. So let's take a look at what this is first before we get into working with Firebase. And I've already kind of pulled it up here. This is what it looks like. On the right, let me know if you can see it. And also let me know if the text on the VS Code is big enough. Okay. I'll take silence as it's all good, Miles. Okay. So just to go over a high-level overview of what this app is, we have two main screens, the home screen and the chat screen. You're seeing the home screen right now. I've pre-built all this, so a lot of it is unrelevant for our workshop. We're just going to focus on Firebase again. And again, just to reiterate, we do not encourage you to code along because a lot of this is pre-built, and we would rather you absorb everything that is directly related to Firebase itself. Okay, but this home screen is pretty basic. It just has, this title, and then it has a input here where you can type in a name. So I can type in my name, and then I can select start chatting, and it'll bring you to this chat area. So this is the chat screen. The chat area, the chat screen is split into two main parts. The chat area on the top where the messages are rendered, and then the bottom here is the text input where you can type in whatever message and send it. So in the code, this corresponds to our chat area is rendered using a flat list, not a scroll view. And so that is taking in this messages array, which is a state variable. And then our input here is taking our user's inputs, and it has a button on the right. So if I type in a message, for example, and send it, it renders on the screen. So cool. We have a little chat app, and we can send our little messages to no one in particular. And also, if you notice, I haven't added any Firebase to this. So if I go back to the home screen and come back, our data is not persisted, right? My message that I just sent, it's not there anymore. All right, so this is why we need Firebase, or we'll need async storage, but because we're communicating with other people, we'll need Firebase specifically. Okay, so the first thing we have to do before anything else, right, we had that config. I did forget to mention that after you've added that config, you want to go ahead and run yarn add Firebase in the terminal so that you can add the package. I've already done this beforehand. It takes a little while, so I'm not going to do it here, but just as a note, you should do this whenever you're using Firebase in your project. Okay. So right now I'm running this on my phone, and that's the overview of this application. Hopefully that all makes sense. We have a bunch of to-dos here, but we'll get into that as we go along. Any questions before we keep going? Looks like a no. Okay. All right, so it's a chatting app. So let's create some logic so we can actually send some messages, right? As we saw before, whenever I send a message, it doesn't actually go anywhere. And also it never stays on the screen when I leave the screen and come back later. So let's go over to our chat screen. And I've created a function here that has you don't really need to know what this does because we're going to get rid of it anyway. But it has an add new message function. And so here we're going to add our Firebase or Firestore logic. So first things first, let's make sure we import Firebase so we can use it. And let's also import our database from our config file. So I'm going to go ahead and import db from /firebase/config. So now we can reference our database from this chat screen file. Okay, back to our adding a new message. So we learned how to add data to our database. We can just use the .add function, right? So let's build our query first. So const query equals db.collection. So our collection here is going to be called chat room. And let me just make this collection really quickly. Chat room. Let's put in one fireside. Let's put in one person here just so we can start it off. the different data that's going to go into each message. This is a good time to go over this. In each message, we'll have a UID for the user who actually sends the message. We will also have the message text itself that we will store. So hello world for now. We'll also have a display name, which is going to be that name that shows up above the person's message. So Fireside Lover 29. We're also going to put in a photo URL because each boy here has a little photo, very cute. And this is going to take an image URL. I'm just going to take one that I found before, copy image address, and slapperdo into here. We'll also have a timestamp, right? Because we want to be able to sort these in the order that they come so that we can get the most recent at the bottom. So let's add a timestamp here. And I'll just set the date for right now. Time is, I don't do military very well, but let's try our best. Okay. And we'll use an auto ID here because it's not meaningful for us to do message 1, message 2, blah, blah, blah. Okay. And I think this is everything we need. So now that we've created this document, we'll go ahead and save. So now we have a new chat room collection with a document inside of it. Perfection. Okay. All right. So now let's get back to our building our query. Right. So now we have a collection called a chat room. So let's reference that. And let's do add here. And we'll pass in a JavaScript object. And so this object is going to have all of these fields in it, all of these boys. And let me bring up the phone again. So we have a UID. This add new message actually passes in a UID, so we're just going to use that one. We also have message text, which is also passed in to here. And this corresponds with the message state that we're using to keep track of what our user is actually inputting into this little text input. So we'll also use that. And then we also need our display name. So display name here is actually from the homepage. If you see, you set your display name on the homepage before you start chatting. So I use some navigation passing to get that. So we're going to do route.params.displayName for that. Okay, we also need the photo URL. I will just use null for now. And then the last thing we need is our timestamp. So timestamp is a little bit special with Firebase. To create a Firebase compatible timestamp or Firestore compatible timestamp, you will do firebase.firestore.server or .field value .server timestamp and then parentheses. So this is there's not really an explanation for this. This is just how it is. This is how you can Firebase lets you or provides a way for you to create a timestamp object. So that's all we need. And now, oh, I realized that I didn't need to create this as a query. Sorry. All we need to do is await this since it's an add. And let's see if that works. I'll save this. Hello. Maybe I need to reload. Downloading. Oh, okay. So we have a little problem here, and it's talking about how I have an await and a non-asynchronous function, right? Because this didn't used to use an await. So let's make sure we add that async, right? So that's a common mistake. Let's just make sure we always have an async if we're using awaits. While I'm at it, let's try to be more good programming and put this in a try catch as well. Console.log and oops, error. Okay, while this is loading, okay, cool. Now we should expect our Firebase database to update when we create a new message. So, oh no, the message is in the way. I need to reload. Okay, perfection. All right, so now I should be able to type in a message here and it should show up. Yep, and we see it shows up in our database, which is really cool. We have a new message here with our display name, message text, timestamp, and our UID. Perfection. Okay, cool. So now we can send messages and they successfully show up in our database. That's great. But you know, like who's actually here, right? I don't have a way to interact with anyone else because there's nothing in our code that actually gets messages from the database. So I'm just kind of here sending messages to the database, but I can't get any messages from the database. So this is kind of lonely. So let's talk about how we can fetch from Firestore so that we aren't as lonely anymore. So we learned about this actually. We learned how we can fetch from a database. We can use a query, right? And this is the specific query that we're going to use. We're going to do db.collection, chat room, and then order by timestamp descending. So we get most recent to least. And then we're just going to arbitrarily kind of limit to only 20. And then we just await and query.get. And recall that to get when we're getting the messages, we probably just only want to do it when the screen loads. So we need to use effect here, so we only do it when the screen loads. Okay, yeah. So we were talking to ourselves. Let's actually try to implement this get new messages so we can get the messages that are already on the on the database whenever we load up our app. Right, okay. So let's go over to this get new messages, and we don't really care what's in here right now. Let's delete it. So this get new messages function, and here we're going to construct a query to get our messages from the database. Because just again, to reiterate, if I'm somebody else, then all of our messages aren't here anymore. But we can add new messages, but we haven't gotten any of them from the previous messages from our database. So we want to do that whenever our screen loads. So let's make a query here. And this is going to be our db.collection chat room. And then we want all of the, we don't want or. We want to order these by timestamp in descending order. And we'll just get the first 20 messages. Okay, so that's our query. Now remember to execute our query. We'll do this try catch. Log error. And then inside of this try, we can do our await query dot get, and this returns our query snapshot. So if you remember, the query snapshot is just what the relevant data relevant to our query looks like at the time of the query. And remember, again, this is await, so it's asynchronous. Let's make sure we have async here so we don't get that complaining anymore. Okay, so now we have a query snapshot, and if you remember, the query snapshot contains a bunch of documents. So let's go through each document, and for now, let's just console log them, just so we can see what we're looking with. And remember, we can get the ID of each document, and we can also get the data in each document, like so. Okay, so let's run this. I'm going to go ahead and save. Okay, it should be refreshed. Let's start chatting. Okay, and now we see in the console. Let's check it out. Cool. So here it looks like we got all our previous messages. Like, hello, Mile, like, who's here? And our yeet, hello world, blah, blah, blah. So we got all our messages and we console log them. Now let's actually update our state, right? So I remember I said that the way it's rendering all of our messages is using this messages state variable. So let's go ahead and using this logic, let's use the data from our documents to make a new messages array with all the documents we received from the database. So what I'm going to do here is I'm going to create a temporary array called message r, and it starts out as empty. And instead of just logging, I'm going to go ahead and first use our object destructuring we learned from last time to get out our UID, our message text, our display name, photo URL from the doc.data, right? Because our doc.data looks just like this boy right here. And then we can go ahead and do message array.push to add all this relevant information to our array of messages. So we'll do UID. And here's a little shorthand. If the key of the object you want to make is the same name as the variable name, you don't have to do like UID. You can just do UID once. Same thing with message text. I don't have to do this. It's equivalent to just say this. Okay, that's just a little note, but it'll make this a little bit less painful. Okay, and additionally, I do want the ID of my message. So I'm going to go ahead and make a message ID field or property here, and then put the doc.id, which represents our message ID. Okay, so now we're pushing each document's data to our message array. At the end of all this, we can go ahead and set our state using set messages to this message array. Okay, so that's a lot of code. Let me check if anyone has questions while I was doing all of that. Looks like no one has questions. Okay, feel free to drop them in the chat if you do, but let's go ahead and run this now. So I'll save this. Oh, and we see it's already working, right? So before, these old messages didn't pop up, but now as soon as I saved that, this ran because we put it in a use effect to get new messages. So as soon as the screen loaded, we requested from the database, and we got all of our new messages. Perfect. All right. So now, we can get the messages and we can send the messages. All right, we can still send them and they still show up in here in our database. But now we have a problem, right? We're still kind of talking to ourselves. We do have the previous messages from people who were chatting before, but we can't talk to them in real time, right? We kind of expect them to be able to respond right away, but our app only loads the new messages when we load the screen the first time. So we're still kind of talking to ourselves, which is sad. So Operation I don't want to be lonely, right? So how can we get the new messages as they are coming in, right? As people are sending them, how can I get them, right? So maybe we can try to fetch them from the database every few seconds or so. So this means that every few seconds we'll do our query, we'll execute our query, just in case any new messages were added. So remember, a way we can do this, also stream modern onlys. A way we can do this is using set interval. And so set interval is a way for us to call a function every however many seconds we want to call it. And we use it in combination with use effect so that we can only have this interval be set one time rather than it doing it over and over again. So let's try this approach, right? So it seems promising. Let's try this. Bing, bing, bong. So we're going to go ahead and use this listen for updates function. It's empty right now, but this to-do says retrieve new messages as they come. So let's try our set interval approach. So we're going to go ahead and say set interval. And this takes a function as well as an amount of time. So I'll do maybe 10 seconds. And it also takes our function. And this function is what we want to use to get new messages every 10 seconds. So we already made a get new messages. So I'm actually just going to call our get new messages function in here. Perfection. And so instead of this use effect having the get new messages, I'll just have it to listen for updates. All right, so hopefully this makes sense. We're just setting an interval so that it calls our get new messages function every 10 seconds. All right, let me save this. Let me go back to the home screen. Let's become a new person. Oops, oh my gosh. Okay, what did I do? Oh, no, it's okay. It's just loading. Okay, perfect. Okay. So now, I guess we have to wait 10 seconds. Did it not load correctly? It might not have loaded correctly. Oh, let me also get rid of this. We don't need this anymore. Let me reload. Okay. So we're listening for updates. Set display name, boba. Okay. Have I messed something up? Good sir. No, there we go. We just have to wait 10 seconds, right? Okay, cool. So we waited 10 seconds. We got the new messages. We can still send messages. And they still show up in our database. And let's go here. Alex, are you still there?
Yeah.
Can you go ahead and send a message and let's see if I get it. So Alex just sent a message, but we have to wait a little bit before it updates. Okay, there we go. We got hello, this is Alex. Awesome, awesome. So this is actually working. Alex is running his own version on his computer. And we just have to wait 10 seconds to get every new message, right? It's not that bad. I mean, it's unideal, right? It's still kind of lonely. In an ideal scenario, we would expect that we can respond to people in real time and get messages in real time. So how can we fix this? Well, one of the great features of Firestore is that it lets you listen for updates in real time. And so it actually lets you react to changes happening in the database when they happen. And the way they does this is through this kind of snippet of code. Let's also break this down. The first line here is just our query. We're familiar with this. And then the second line here is probably not something we're so familiar. So let's take a closer look. So this part of the code has a line query.onSnapshot. And what onSnapshot is doing is it's creating a listener that's going to react whenever there is a relevant change to our query. So a relevant change in the database to our query results. And this onSnapshot takes a function which it's going to run whenever it detects that change happening. So inside here, in this function we pass in, what I'm doing here is I'm going through each document in our query snapshot that it gives us. And right now we're just logging, but what we would probably want to do is set our state or something like that. And then one note here, there's this unsubscribe thing. All this is it's the query.onSnapshot returns a function to stop listening to database changes, which is actually useful so that you don't continuously forever keep listening while your app, even if your app is not on the relevant screen. So this kind of limits the amount of calls you're doing to your database. Okay, so real-time interaction. Let's do it. Hog. Okay, so this was unsatisfactory, still kind of lonely. So let's get rid of this for now. And let's instead go ahead and do our listening for real-time changes. So we can always create our query first. DB collection users dot order by timestamp in descending order. And we only want the first 20. Okay, and then now we just set up our onSnapshot event listener. Oops, I can't spell. I still can't spell. Unsubscribe. Query.onSnapshot. OnSnapshot. And the onSnapshot, remember, takes a function. This function will give us access to a snapshot whenever there's a database change. And we're going to go through each document and add it to an array. And so this is the same logic as when we were getting messages. So let's just copy paste that in here. All right, so again, temporary array, go through each document in the query snapshot, and then set the state to the new messages. Okay, and let's also add a return subscribe, unsubscribe, so that we can use that to unsubscribe from listening. So let's save this now. And let me get out of here and reload. Shake, reload. Okay, now let's get I'm a new person now. Oh no, did I do something wrong? Unsubscribe, onSnapshot, listen for updates, use effect, listen for updates. I might have made a small error somewhere. Let me make sure I didn't miss something. I should be good.
Wait, I think
oh my gosh,
your collection is supposed to be chat room, not users.
Yeah. My bad. Chat room. I wrote users for no reason. Okay. Okay. So now I should be able to send some messages. And Alex, why don't you go ahead and send some messages to me as well? Hey, dude, that's so sad, bro. Why? Right, so now we can communicate with each other in real time. I'm adding to it and he's sending back to me and I get them right away. So this is our real-time interaction. Okay, awesome. And that does it for our demo app. But does anyone have any questions before we kind of wrap up a little bit? Okay. Okay, so just to leave off on some stuff for you guys, we went over a few different things you can do to your database, like add, delete, and update, but we only really worked with adding in our demo. So for a challenge for you guys, on your own time, try to see if you can add the two following features where you can have users delete their own messages or edit their own messages. So that'll let you cover that delete and update that we also went over. And also here's full docs for Firestore. There's a lot to what you can do. I couldn't cover it all in this workshop, so I have put links to all the extensive docs that are surprisingly readable. So go ahead and make use of them. And that will do it for us. Please fill out our feedback form and also Facebook guest speaker next session. One thing before we wrap up is there's extra content for this workshop, but we just couldn't fit it in today. As you can see, there's already kind of late. So this is going to be going over Firebase Authentication. And Alex has gone ahead and recorded this section of the workshop. So that will be posted in the Discord later on and also on YouTube. So you can go ahead and watch that on your own time if you want to learn about how to put authentication in your projects as well as Firestore. Okay, other than that, please fill out the feedback form. Really appreciate it. If you do, it helps us a lot. And come out next week for our Facebook guest speaker. Woot, 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 woot.